Hi, I'm Larry Johnson. I'm a professor at Texas A&M University. We want to talk about the cardiovascular system, the types of capillaries, with features, functions, and locations of the different types of capillaries.
And so the capillaries are actually of three types. You have the sinusoidal, which is the greatest one, got gaping holes in the vessel wall. In order to have that type of vessel, you have to have the epithelial cells have to support the wall, and that's what happens in the liver. And then we have a fenestra, which are little holes in through there, and we see those in the kidney and adrenal for flow to occur, and that is fluid flow through the vessel. And then in some places, the brain, the muscle, we have a continuous capillary, continuous such that you don't have a lot of flow of fluid out. Nutrients might migrate through, but you don't have fluid. You can't have edema in muscle or the brain. And here we can see those different ones. The continuous one has a cell all the way through. Here it's got a distinct basal lamina in through there, and transport occurs in vessels. So you have vesical transport. In fenestrated, you have little holes in there that fluid can go through. You have that in the kidney. You have that in the adrenals. And then in the liver, a sinusoidal, this is a hepatocyte in through there which supports the vessel, but you have these gaping holes. And so that the fluid itself bathes the hepatocyte is what you have there. Quite a bit different than what you would have in muscle or brain or even the testis. So you have to have continuous capillaries in there, but there are some places you have gaping holes in the wall. So in terms of the different types, you have continuous capillaries, you have fenestrated capillaries, and you have discontinuous capillaries. The basal lamina is complete. All epithelium sits on basal lamina, and endothelium is an epithelium, so it sits on the basal lamina, but it's incomplete, or maybe lacking in some places in the discontinuous or the sinusoidal. And so examples of the continuous, as we said, brain, muscle, testis, thymus. For the fenestrated, adrenal, glomerulus, and the kidney. And then the discontinuous would be the liver, spleen, bone marrow. And these other two are part of the immune system, and you have to have blood cells migrating through. So you need a pretty big hole for them to be able to get through easily. Here we see in the adrenal, there's the capsule of adrenal, and then here we can see the little sinusoidal vessels that go through there. This is the cortex and the medulla, but right in through there is where we see endothelial cells, which are fenestrated. In the liver, we can see the sinusoidal ones, and as I mentioned, the epithelial cells have to support the blood vessel, and that's what you see. So the blood vessel doesn't want to pop out because the epithelial cells, the functional cells, the hepatocyte, is supporting the structure of the wall. Another place is in the bone marrow. Here we see a piece of bone in through here. This is one of the ribs, and if you look inside there, you can see the sinusoidal vessels. It's the endothelial cell that goes around through there, and that is a sinusoidal. You can see another one right in through there where red blood cells and white blood cells are produced outside the blood vessels, and they have to migrate in, and so you need a pretty big hole sinusoidal to accommodate that. Here we see in muscle, this is continuous capillaries. We see another continuous capillary. This is the endothelial cell. There's its cytoplasm in through there in a skeletal. This is cardiac muscle. Cardiac muscle, you can see the intercalated disc there. And so continuous capillaries, you see in through there, there's a endothelial cell, and there's a little pericyte that's associated with it. Here's muscle in the tongue, and we can see the continuous capillaries. So you see the endothelial cells are actually branching in through there, multiple branching as it carries blood from cell to cell. We can see the capillaries in through there. These are continuous capillaries, that are in muscle of the tongue. Also, we can see endothelial cells and lymphatics. And in the intestinal villus, it has a central central lacteal that's in there. You can see one here. You can see parts of one over there, parts of one over here. This is a central lacteal there, lined by endothelial cells. It starts up there, and then it also comes down through the base to carry fluid back and fat back to the bloodstream via the thoracic duct, and that doesn't go through the liver first. Other nutrients go through the liver before it goes throughout the body. And then here we see the bile duct, and we see a muscular artery. We see that the blood vessels were perfuse fixed, and so the fixative took the blood out of the arteries and veins. However, in the lymphatics, it could not remove it, and so that's what we see. These are actually lymph vessels, and you can see there's valves that are in the lymph vessels. So that with the pink in here as opposed to the white is indicative of a lymph vessel that when the tissue was perfuse fixed, or the fixative was washed through the blood vessels and not just thrown into the fixative. So these are lymphatic. You can see the endothelial cells, and usually the endothelial cell lining there are very, very thin, and also the lymphatic vessels have little things that tie them down that holds them open as well.
We want to thank the original sources of illustrations and images that were used in this presentation. So that's the end of the cardiovascular system regarding the types of capillaries, features and functions and locations of these different types of capillaries.